Okay, all right. So here's what we're gonna do today. All right, in day two of this new unit, which is square root functions. Okay, so now we're kind of taking another thing that we learned much early in the year and start examining it and see what it does to a graph. Okay, and then I'll give you the intro, and then afterwards I'll show you what the transformations look like. Okay, and that'll be it. Okay, all right, let's go. All right, so write this down. Okay, square root functions. And then let's take a look and see what it looks like. Okay, all right, now, whereas just as when we were doing the absolute value function, we had to briefly talk about what absolute values are. We'll do the same thing with square roots with a 8th grade perspective, okay? So now, here, square of 9, right? What's the square of 9? In other words, what times what can give you 9? Yeah, 3, right? But don't forget, at the 8th grade level, it's not just positive 3, right? What would it be? Yeah, negative 3 also, because negative 3 times negative 3 can also give you positive 9, right? So for 1, right, what's the absolute value? I mean, what's the square root of 1, right? Plus minus 1, right? And what about 0? Now, please don't say plus minus 0. That does not exist. It's just 0, right? Okay, let's take a look then. Now, here, what we're going to do is this. First of all right, if we were to look at a table of values, right, and so looking at this function here, and we're trying to graph it by hand, right, think about this for a second. If you were trying to, you know what, I'm going to start from the bottom and work the way up to the top, okay? So let's take a look at this, right? So if I try to take the square root of positive 9, right, what are the two possible values for y, right? Well, it's plus or minus 3. So that means you got 2 points there right off the bat, right? If x is 9, then the answer could be 3 or negative 3, right? You see why I have to write both of them like that, right? And then we take the square root of 4, we can get the positive and negative roots of 2, which means it could be 4 comma 2 or 4 comma negative 2, right? Same thing with the square root of 1. Right, it'll be positive minus 1, right? Now, notice how I pick these numbers, right? I pick perfect squares for a reason, because I don't want to deal with decimals, okay? So if you were to ever have to graph this by hand, all right, with no calculator, which is impossible at this point, right? You have to pick numbers that are like, you know, nice and, whole numbers, right? Okay, so 1, 1, and 1, negative 1. Now let's go to 0, square root of 0, 0. So it's just 0, 0. Now, I picked the negative number for a reason, all right? Because, now think about it. What number times itself would give you negative 4? Yeah, nothing. There's no, it just simply doesn't happen, all right? Now, in the 11th grade, or 10th grade rather, maybe 11th, right? There's something called an imaginary number, but this is not the time or place for it yet, okay? Now, let's graph this. So here we got 0, 0. All right, we got 1, 1, and 1, negative 1. All right. Now, okay, all right, so let's keep graphing, and then I have something shocking to tell you. All right, so let's see. 2 is not that shocking, okay? I'm just exaggerating, as usual. All right, so 4, wait, hold on, it's 4. Hold on, let's see, 1, 2, 0, 1, right, and then 2, 4, 1, 2, 3, 4, positive 2, and negative 2, all right, and then 9, which is all the way out here, so I don't have space for it, all right, so I'm just gonna do my best here. All right, I know that 9, 8, 9, so it'll be 9, 3 like this. Maybe 1, 2, 3, something like that. Okay, all right. Okay, now let me connect these. I'll try to do my best. Like that, all right. Now, here's the thing. So if you put this in a graphing calculator, let me show you how to do that first, okay? Let me make sure I'm recording. All right, I'm recording, good. Okay, all right, now, here, let's graph this. Now, I already put this here, All right, so let me do it one time with you guys. All right, so I go to square root. Now the square root's right here above the x squared. So I'm gonna go to second square root, right, like that. I'll put x in there. All right, go to the right, slide out of that symbol. All right, and then graph it. Now this is a bit of a shocker. Uh-oh, what's going on here? It doesn't match ours, right? Ours is like a sideways U, right? This one is not even. It's just a line here. Does anyone know why? Because I had to look this up for a second. I was kind of worried for a second. I was like, oh man, I have to spend like another 15 minutes on this. Yeah. Remember the vertical line test? What does a vertical line test tell you? Yeah, it's whether something is a function or not a function, right? So what happens if I put the vertical line on it? So meaning, let's say I take a ruler. If I go like that, right? And I just remember what I said. I said just slide your ruler across, right? If the ruler crosses the graph at more than 1 point, so 2 points for example, then it's not a function. So you see how like this graph would fail the vertical line test, which would make it not a function, but that's not good, right? Because the topic of this lesson specifically is that we are examining this square root specifically as a function. So what does that mean? We gotta erase this part. That's what that means. Okay, so that's why your graphing calculator displays the graph like this. Okay, all right. Okay, now let's see. Let's talk for a second. Okay, now let's get into the transformation part. So the transformation, therefore, right? So we got only a couple of things going on here, because there are two things we can examine here. One is what's happening strictly inside the radical symbol, right? Meaning this is what I mean. Parent function, what happens when we subtract inside the space? Now, what was the example I used? All right, -3. And what happens when the subtraction takes place, or addition really, right, takes place outside of the radical sign? So can you discern the difference between the second one and the third one? Right? Okay, so let's take a look. Now, again, we're starting with the parent function here, right? Square root of x. All right, what happens if we add 3? Oh, here we're adding. Oh, okay, all right, that's fine. When we're adding like this, what happens? Goes left. It's kind of like the vertex form, okay? Right? We're adding 3, but we went left 3 spots instead, right? 1, 2, and then 3, right? Now, let's see what happens when we are subtracting. All right, so again, this is your parent function, and again, try this on the calculator if you like to. All right, we got a parent function like so. When we subtract like this, inside, it goes to the right 3 times. 1, 2, 3, like that. Okay, now, what happens if we have one more thing. What happens if the sign outside is a negative? The graph, this was the original, right? The graph flips upside down, like that. Okay? All right? I'm going a little fast because sometimes I feel like even though the topic's a little different, I feel like we're all saying the same things over and over at this point. Here, right? What happens when something is happening outside the radical sign? So here we got our parent function again, right? All the way on the right side. If you add 3 outside, hey, look what happens. It lifts the graph up 3 spots, right? And similarly, if you subtract, it lifts the graph down 3 spots, but it doesn't turn it upside down. Notice, right, how this is not turned upside down the way this was, right? So this subtraction of 3 outside the radical has nothing to do with flipping the graph up and down, okay? Like a reflection, actually. Okay, all right. Let me show you like 1 or 2 Regents questions, and then that's it. I want to keep this one short. I don't don't want to make this unnecessarily long. Now, here, I mean, look, that's a Regents question. I mean, look what they're asking you. He's like, hey, do you guys know how to use a graphing calculator? If so, do this and just pick a picture, all right? And just by looking, you know it's not these two. Well, actually, not these three, that's it, all right? Look, you don't even need to use a calculator. Just look, right? -2, 2 spots to the right, right? So it's not tough. For this one, right, you put in the graphing calculator. Let me show you one time real quick on how to do that. Let's see, clear that. Now here, I'll go to my square root of x. Now, don't immediately write -1. You have to go right first and write -1. Okay, got that? All right, and then you graph it, okay? The graph's gonna shift 1 unit down anyways. All right, that's what that means, all right? For this one, actually, let's talk about this one. For number 4, over the domain, what it really means is this, okay? Let's put that in there for a second. Clear that. What is it? Square root of x plus 2. Let's see, square roots. Second square roots of, now, this one is x plus 2, right? Like that, and then you graph it. Now, what are they talking about from between -2 and -7? Inclusive, right? Including -2 and 7. Well, go to table of values. What they're saying is, hey, don't go beyond -2 for the independent variable, right? Because you see how these are errors, right? So they say basically just graph it. Now, how is that possible for a second, right? Let's talk about that. If you put -2 here plus 2, that's the square root of 0, right? Once you put -3 in there, you get the square root of -1. You can't have that. That's an imaginary number. Can't graph it, okay? Not right now, at least, right? So that's what they mean. So they want you to graph it from -2 all the way to +7. So meaning only graph the values from -2 all the way down to 5, 6, 7, like that, right here. From here to here. That's what they would like you to graph, okay? And then you graph it. That's it, all right? And make sure you label it, all right? Same thing, and that's it. Okay, all right, that's that. Yeah, that's it. All right, yep. Tomorrow we're gonna spend 2 days on step and piecewise functions, and then that'll be that. Okay, all right. Thanks for watching. Have a good day. I will see you tomorrow, all right? 2 lessons left, okay? All right, bye-bye.
OMG, that was so good.